India successfully completed the first lunar mission in 2008. The Chandrayaan-3 spacecraft, which found water on the moon, elevated India and ISRO to prominence. The next lunar expedition planned by ISRO was even more critical, specifically Chandrayaan-2. Following almost 10 years of planning, India executed the Chandrayaan-2 mission. Unfortunately, though, the probe crashed and was destroyed on the moon's surface as a result of technological issues. However, ISRO investigated the cause of the failure, took what it learned, and retried the mission with higher perfection rather than wallowing in its defeat, specifically Chandrayaan-3. At this moment, Chandrayaan-3 is getting ready to touch down on the moon. The landing phase of the mission is significantly more important than any previous phase to yet. A few days ago, during landing, Russia's Luna 25 lost control and collided with the moon. All of the difficulties that Luna 25 and its scientists encountered that day will also be experienced by Chandrayaan-3. The question of whether we can conquer it all is a difficult one. If you're wondering if everything has gone according to astrophysicists' expectations since Chandrayaan-3 was launched, the answer is unquestionably no. There were numerous small issues. The scientists swiftly made corrections while continuously keeping an eye on everything. There could be a lot more issues like this for Chandrayaan-3, particularly during the landing phase when the scientists are all holding their breath. What difficulties is Chandrayaan-3 going to encounter? How does our ISRO plan to handle a situation if something goes wrong? What kind of crucial final moments will Chandrayaan-3 land? I'll see. Space missions come in multiple stages. Every single phase of the process is crucial. Chandrayaan-3 requires the highest level of precision at every stage, from launch to moon landing. In the event that anything goes wrong at any time, the mission could end in failure. A week ago, Chandrayaan-3, which was launched on the 14th of last month, achieved a significant milestone. The crucial phase was when the Vikram lander separated from the propulsion module, enabling Chandrayaan-3 to reach the moon. As a result, the lander started orbiting the moon independently after separating from the module. August 19th, 2 days later, saw the completion of the first deboosting. Deboosting is the process of reducing the lander's speed in order to get closer to the moon. The lander's own engines are used to carry out this deboosting procedure. Its orbit will contract and become more elliptical during this deboosting. The initial deboost of the Vikram lander took place at a distance of 113 by 157 kilometers. That is, it traveled 113 kilometers to reach its closest point to the moon's surface and 157 kilometers to depart. However, a safe landing on the moon will only be feasible if it gets closer than this. So deboosting was carried out once more on the 20th. The second and last deboosting was that. According to ISRO's plan, the lander will be in an orbit 30 by 100 kilometers when the second deboosting is completed. Still, there remained an issue. The orbit's diameter is shifted from 30 by 100 kilometers to 25 by 134 kilometers. They did, however, find a solution upon landing. We're aware of the significance of the final phase, landing. The entire world is awaiting that 1 second, eager to find out what will occur. It's scheduled to circle the moon at its present extent of 25 by 134 kilometers until 5:45 p.m. on August 23rd, according to astronomers' plans. Why are there so many days involved? Would it have been able to land on the 20th? It isn't feasible to go so soon, because before it touches down, it must pass a number of checks. That is, tests to verify that every piece of equipment is functioning as intended. A malfunctioning piece of critical equipment will impact the landing. Therefore, at the moment of landing, it must be daylight on the moon. For only with adequate light can the entire surface be seen properly, allowing the lander to land precisely where it's intended to. It did not land on the moon right away for all those reasons. Thus, all the testing will be finished this evening and the setup will be flawless. The Chandrayaan-3 landing consists of 4 primary stages. Around 5:45 is when it's time to land, and at that point the rough braking phase starts. During this phase, the lander's engines will be activated first. The lander will then enter a slower orbit around the moon. At the moment, Vikram lander is traveling at a speed of roughly 6,000 kilometers an hour around the moon. This speed is decreased with thrusters. At that point, lander will gradually descend from its 25-kilometer height owing to the moon's gravity. Vikram will ascend to a height of 7.4 kilometers in 11 minutes from his current height of 25 kilometers. Furthermore, the speed will decrease to 1,260 kilometers an hour from a maximum speed of 6,000 kilometers an hour. This speed is horizontal. That's how quickly the moon orbits the Earth. The vertical velocity, or the speed at which one descends to the moon's surface, would be roughly 220 kilometers an hour. At this point, Vikram lander will be moving horizontally as seen in this image. However, its posture will be reversed and brought into a vertical position when it reaches a height of 7.4 kilometers. The second phase is to turn to the vertical position. We refer to this stage as the attitude hold phase. There will only be 10 seconds in this step. That is, it takes the lander only 10 seconds to spin around. When the turn's complete, it'll have ascended to a height of 6.8 kilometers. It'll cut off 2 of its 4 thruster engines once it reaches this altitude. After then, only 2 engines will be operating. It'll immediately start scanning the lunar surface after reaching vertical position. Images and data of the lunar surface have already been stored in the lander's memory. The lander can then determine whether it will land in the same spot as seen in that picture. And with that, the third stage starts. We refer to this stage as the fine braking phase. At this point, rockets will be used to gently lower the lander to the moon's surface. It entirely switches to vertical position during that moment. It ascends to a height of 800 meters in roughly 3 minutes. At that point, the lander's vertical and horizontal velocities will both nearly zero. In other words, it'll hover 800 meters above the ground in a manner similar to a helicopter. That's how it remains for a mere 22 seconds. It's not just standing around these 22 seconds. At this point, the lander's cameras and sensors will all be turned on. The lander's computer will evaluate the data they received from them and decide where to land. It will then descend once more. The final phase, known as the terminal descend phase, then starts. It'll soar like a helicopter once more for 22 seconds. Or until it reaches a height of precisely 150 meters. It carries out hazard verification at that point. In other words, it determines whether the landing site is secure. In the event that large boulders, pits, or other hazards are present, Vikram lander is able to land up to 150 meters from the planned location. The lander also has a very precise laser Doppler velocimeter to measure the altitude during descent. In any case, the Vikram lander will ascend to a height of precisely 10 meters above the ground at the conclusion of the terminal phase. Its thrusters will abruptly all halt at that point. After that, it will descend to Earth from a height of 10 meters. Why was the lander dropped from such a height through such agonizing efforts to get there with such precision? Its rockets will shoot all the dust into the air and fill the lander if it attempts to land with them blazing. That may cause harm to the lander's machinery. Relative to a drop from 10 meters, however, the dust does not fly as far. It'll strike the Earth at a speed of 2 meters per second. However, the lander is made so that nothing happens even if it strikes at 3 meters per second. After then, all landing steps will have been finished. The landing procedure will take 15 to 20 minutes from the beginning of the first stage until the touchdown. Both the space fans and the science team behind this will have a fire blazing inside their chests for this 15 minutes because anything may happen in these 15 minutes. This is so important that it's dubbed 15 Minutes of Terror. India will become the 4th nation to soft land on the moon if everything goes according to plan. When the landing-related dust is settled, which will take some time, Vikram's door will open and Pragyan will emerge from within. For each of these phases, ISRO has a backup plan in case something goes wrong. The landing site of Chandrayaan-2 occupied a mere 500 by 500 meters. This implies that it ought to have landed in this constrained space. However, Chandrayaan-3's landing area measures 4.5 by 2.5 kilometers. Landing is therefore simpler. Compared to Chandrayaan-2, Chandrayaan-3 has greater fuel. Because of this, Chandrayaan-3 will not have any issues even if it needs to land a little bit off from the intended landing place. We lost contact with it in the Chandrayaan-2 mission as well, similar to what transpired with Russia's Luna 25. However, ISRO has furthermore set up a framework for orbiter-based communications this time. To put it briefly, ISRO was ready to set foot on the moon. Let's observe the outcome of this.